Okay, let's go ahead and get started. And right now we're going to talk about our quadratic functions, and we're going to be talking about how to find the vertex for a function. As you'll recall, a quadratic function is just the function associated with a parabola, and the vertex is the lowest or highest point of that function. So the vertex is a very, very important point. We can't really graph a parabola without knowing it, because it is essentially the center of all of our calculations. So let's talk about finding the vertex. And incidentally, this is one of the things that we can use to also help us convert between our two forms. So recall we had our standard form of a parabola, which was our standard quadratic function is ax squared plus bx plus c. This is that standard form. And we had our vertex form. This is the same value of a, believe it or not, of x minus h squared plus k. This is called the vertex form. Please forgive me, got some background noise out here. Anyway, now our vertex is really easy to get from the vertex form, as you might guess. The vertex is just given by that h and k. So if I'm given something in our vertex form, let's say we've got something like f of x is equal to x minus 3 squared plus 4. One of the things that we're going to do is we can read right off of here what our vertex is. So we take this first value inside the set of parentheses, and we're just going to flip the sign on it. This is a minus 3, so I know that my x value for my vertex is going to be a positive 3. I'm going to keep the sign of this one, so my vertex here is just going to be a positive 4. Okay, that's pretty easy. We're just reading these values. Remember, we flip this sign. So, let's do it again. Let's say I've got a function where I've got like x plus 2 squared, and I'm going to do like a minus 6 this time, just for fun. Well, once again, I'm going to flip this sign. So here my vertex for this equation is going to be negative 2, and this time I keep this sign. Well, I always keep the sign for this. So this is going to be a negative 6. All right. Let's do it again. Let's say I've got a function that is, let's do something a little bit different. I'm going to throw a value of a that isn't just 1. I'll do 2 times x plus 6 squared plus 2. And you might think that this value would impact this, but it doesn't. It's whatever value is in here with the x. So here, once again, we flip the sign on this term, so this is going to be a negative 6, and my k is going to be a positive 2. Here we just have this is going to translate to a stretch factor. All right, let's do it again. Let's say we've got, I don't know, f of x is equal to negative x minus 5 squared and minus 1. Oh my gosh, all these negatives. What do? Panic is not one of the steps. This negative isn't going to impact anything in here. So we're just going to say our vertex is going to be, again, we flip this sign, so that's going to be a positive 5. And our y value is a negative 1. So given something in vertex form, it's really quite straightforward. We don't have a lot that we need to worry about. We can read it directly out of our equation. Now, in standard form, that's a little bit different. And we can, there's actually two different ways of getting there. I'm going to show you both of them, but I'm going to show you my favorite method first. So, our standard form, like I said, is this f of x is equal to ax squared plus bx plus c. So what we're going to do with this is we're going to just say that our h value is negative b over 2a, and k is just equal to whatever that function is at h. So let's do a couple examples, and I'm gonna do, let's start with our first example here, and I'm going to say, I'll go really easy. I'm going to say f of x is equal to x squared minus 2x minus 3. Okay, here my a is equal to 1, because even though I don't have a value in front of this x, we have this implied 1 right there. My b is negative 2, my c is negative 3, although that doesn't impact our calculation. So when we say our h, this is just, again, that negative b over 2a, this is going to be negative 2 over 2 times 1. Oh, that looks like it's going to be negative 2 is a positive 2 divided by 2, which is just a 1. Okay, there's our h. Our k, as we said, is just our function at h. So here, this is just this function at 1. And that's going to be 1 squared minus 2 times 1 minus 3. So this is 1 minus 2 minus 3. So it's going to be 1 minus 2 is negative 1. Negative 1 minus 3 is negative 4. And that happens to be our k value. So I could say that my vertex here is at 1, negative 4. And one of the nice things with this is this allows us to rewrite our function in vertex form. I have this value of h and k, and I already know my value of a. So I could just, if I wanted to, say, oh, well, remember that f of x is equal to this a x minus h squared plus k. Well, here, my a value was 1, so this is a 1. My h value was 1, so it's going to be minus a 1. And my k value is minus 4. So if I were to rewrite this, this would just be x minus 1 squared minus 4. And if I were to FOIL this out, I would discover I get my original function right back out again. I did promise you I would show you another way of finding your vertex, and that's actually pretty straightforward as well. With this, we're just going to complete the square. To find the vertex. I'm going to try a different function here. I'm going to say, let's say we've got f of x is equal to x squared minus 6x minus 15. Now, we're going to be doing something a little bit different when we complete the square, because when I do this, remember, I always have to add something to both sides. Well, I don't always have to just add to both sides. I could also just as easily add 0. So what I'm going to do is I'm going to leave myself a gap here. So x squared minus 6x. And I've got this minus 15 over here. And think about what we do whenever we complete the square. I always take a look at this middle term and I say, well, what is half of my middle term? Well, half of my middle term here, thinking about this, negative 6 divided by 2, that's just negative 3. So negative 3 squared is 9. So what I'm going to do is I'm going to add 9, but I'm also going to subtract 9. So notice that all I've really done, if I were to add this all up, these terms would just cancel each other out. But what I can do now is I can factor these, because now I have made a perfect square trinomial. This is just going to turn into x squared, what did we have up here, minus 3, oops, sorry, not x squared, my apologies, minus 3 squared, and now I can go ahead and combine these other two terms. I have minus 9 and minus 15 is going to give me minus 24. So from this point, I can directly read off of here what our vertex is. Our vertex, remember we flipped this sign, our vertex is going to be 3 and negative 24. And that's how we go about finding our vertex given any version of a quadratic function. Alrighty, that's it for now. I will catch you in the next video.